Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel. Dear students, in this video we are going to study about the topics refraction, Snell's law, angle of deviation due to refraction, simultaneous reflection or refraction, principle of reversibility, relative refractive index.
Dear students, in this video we are going to study about the topic refraction. Let us see what is refraction of light. Refraction is passing of light from one optical medium to another optical medium through a boundary. In refraction, the angle of incidence I in one medium and the angle of refraction R in the other medium are measured with respect to the normal drawn to the surface at the point of incidence of light. What are the laws of refraction? There are two laws. The first law states that the incident ray, the refracted ray, and the normal to the refracting surface are all coplanar. That means they all lie in the same plane. The second law states that the ratio of sine of angle of incidence I in the first medium to the sine of angle of refraction R in the second medium is equal to the ratio of refractive index N2 of the second medium to the refractive index N1 of the first medium. So this law can be written as sin I by sin R equal to N2 by N1. The above equation is in the ratio form. It can also be written in a product form like this. N1 sin I is equal to N2 sin R. The law of refraction is also known as Snell's law. The refraction at the boundary is shown in this figure. Here, this is the medium which separates the air above, and this is the normal drawn to the surface, and on this surface refraction will be taking place as an incident ray is falling on it, and this is the refracted ray. The air medium has a refractive index of N1, and the medium in which the light gets refracted is given by N2. This is the refractive index of the second medium. Here the ray of light bends towards the normal, and here I is the angle of incidence and R is the angle of refraction. And for normal incidence of light on a surface, the angle of incidence is 0. Now let us study about the angle of deviation due to refraction. What is angle of deviation? That is the angle between the direction of incident ray and the refracted ray. That is called angle of deviation due to refraction. When light travels from rarer to denser medium, that is from air to water or gas, it deviates towards the normal as shown in this diagram here. So here the ray, that is the refracted ray, is bent towards the normal. The angle of deviation in this case is given by d equal to I minus R. So this is the angle of deviation that is given by I minus R. In this case, the refractive index of the first medium is less than the refractive index of the second medium. That is N1 is less than N2. Similarly, if the light travels from denser to rarer medium, that is like this, it deviates away from the normal as shown here, and therefore the angle of deviation in this case is given by d equal to R minus I, so as shown here. In this case N1 is greater than N2, that is the refractive index of the first medium is greater than the refractive index of the second medium. Now we will see what is simultaneous reflection or refraction. In any refracting surface there will also be some reflection taking place, which you would have seen in a glass plate. Thus the intensity of refracted light will be lesser than the incident light. The phenomenon in which a part of light from a source undergoing reflection and the other part of light from the same source undergoing refraction at the same surface, that is called as simultaneous reflection or simultaneous refraction, and that is shown here. Such surfaces are available as partially silvered glasses. So here this is the incident ray and this is the reflected ray, and refraction will also taking place simultaneously. Here the angle of incidence is given by I, and here also it is I, and the angle of refraction is given by R. And here the production of optical surfaces which are capable of refracting as well as reflecting is possible by properly coating the surfaces with suitable materials. Thus, a glass can be made partially see-through and partially reflecting. These glasses are commercially called as two-way mirror, half-silvered mirror, semi-silvered mirror, etc. This gives a perception of regular mirror if the other side is made dark. But still, hidden cameras can be kept behind such mirrors. We need to be cautious when we stand in front of mirrors kept in unknown places. There is a method to test the two-way mirror. Place the fingernail on the mirror surface. If there is a gap between nail and its image, then it is a regular mirror. But if the fingernail directly touches its image, then it is a two-way mirror, like this. Now, what is the principle of reversibility? The principle of reversibility states that light will follow exactly the same path if its direction of travel is reversed. This is true for both reflection and refraction, as shown here. Then, what is relative refractive index? This in the equation 6.18, the term N2 by N1 is called relative refractive index of the second medium with respect to the first medium, and that is denoted as N21. And N21 can be written as the ratio of N2 to N1. And the concept of relative refractive index gives rise to other useful relations such as the inverse rule, which is given by N12 equal to 1 by N21, or N1 by N2 equal to 1 by N2 by N1. The chain rule is given as N32 equal to N31 into N12. That can be written as N3 by N2 equal to N3 by N1 into N1 by N2.